Okay, ladies and gentlemen, welcome to the 2-8 video lesson. This is the final lesson of Chapter 2. This lesson is going to take the information that we learned back in Chapter 1, Section 5 about angle pair relationships and start to apply those rules to proofs. Now, there are a number of new theorems and postulates. This video will cover the new theorems and postulates. And then there will be 5 proof examples in these notes. There are no proof examples in these notes because we already should know how to do the non-proof questions based on section 1-5. So here we go. First up, we have the angle addition postulate. This is a new postulate that is extremely similar to the segment addition postulate. It says that if D is in the interior of angle ABC, or D is in the interior of angle ABC, if and only if the measure of angle ABC is equal to the measure of angle ABD plus the measure of angle DBC. In other words, the measure of the large angle in the picture is equal to the measure of the two smaller angles being added together. In other words, the angle addition postulate says that adjacent angles can be added together to form a larger angle. Okay, that's more or less what the angle addition postulate is saying. The big angle is equal to the sum of the two smaller angles. Now that, unlike chapter 2, section 7, the only new rule we had was the segment addition postulate. But here there are several other new rules based on vocabulary words that we already have in place. So here are 2 more rules. These are the complement and supplement theorem. Okay, both of these could be used as excuses in a proof as well, so we're going to go through these 2. The supplement theorem says that if 2 angles form a linear pair, so linear pair being the vocabulary word, then the angles are supplementary. So in this picture we have angle XYW and angle WYZ form a linear pair. Again, that is a vocabulary word, and I told you at one point if you didn't know that word, you were going to be in trouble. We have reached that point. Notice those 2 angles, when we put them together, form a straight line. That's why they're called a linear pair. That means that the measure of those angles, the measure of XYW plus the measure of angle WYZ, add up to 180 degrees. They are supplementary. Okay, those vocabulary words are words we have to know. The complement theorem says if the non-common sides of 2 adjacent angles, there's a vocab word again, form a right angle, then the angles are complementary. And I'm actually going to take that a step further here. In that picture, the common side of the 2 adjacent angles, which are this angle and this angle, the common side is ray FH. So the non-common sides would be ray FE and ray FG. Those are the non-common sides of those 2 adjacent angles. They are perpendicular, meaning that they form a right angle. See boxy in the picture? This indicates that those 2 together form a right angle. That means that the measure of angle EFH plus the measure of angle HFG must be complementary, meaning they add to 90 degrees. So again, there's a bunch of vocabulary words in there. If we don't know perpendicular, if we don't know right angle, if we don't know supplementary, complementary, adjacent, these are things that are a problem at this point. So there's 2 new rules that we could use in proofs, and we will in the example proofs in this section use the supplement and complement theorem, each in a different proof. Okay. In addition to the new theorems and postulates, angle congruence is reflexive, symmetric, and transitive, just like segment congruence was. So again, the reflexive property would say that an angle, such as ABC, is congruent to itself. Okay, so we're saying every angle is congruent to itself. That's what the reflexive property says. Which on the surface doesn't seem very useful, but we will use it from time to time in proofs, especially in Chapter 3. So it is very important that we have that available to us. I'm sorry, Chapter 4, not Chapter 3. We will use the reflexive property quite a bit in proofs this year, so we need to have it in place. The symmetric property says that if angle ABC is congruent to a second angle, call it DEF, then we are allowed to switch the left and the right sides and state that angle DEF is also congruent to angle ABC. So that the symmetric property is saying that we are allowed to reverse a congruent statement. The left and the right sides are interchangeable. And finally, the transitive property, I'm going to cheat a little bit and use our shortcut names, says that if angle 1 is congruent to angle 2, and angle 2 is congruent to a third angle 3, then that means that angle 1 is also congruent to angle 3. Remember that for the transitive property, it absolutely must match that pattern exactly. It cannot deviate from that pattern at all in any way. It must say if 1 is congruent to 2 and 2 is congruent to 3, then 1 is congruent to 3. It must go in that exact order. Okay, the final theorem, I believe, in these notes is the vertical angle theorem, which states that if two angles are vertical angles, then they are congruent. So in this case, angle ACB and angle DCE are vertical angles. They're not the only pair in that picture, but that's the top angle here and the bottom angle, those two angles, which means that angle ACB is congruent to angle DCE. That is what this rule says. Okay? That is what this rule says, and this fact that I screwed up this C is really bothering me, so I got to fix that. Okay, keep in mind that there is a second pair of vertical angles in this picture as well. Angle ACD and angle BCE are also vertical. Which means that angle ACD is congruent to angle BCE as well. Okay, every pair of vertical angles must be congruent. That is what this section says. Okay? I think that does it for our first video. It does. The next video will cover, I believe, 3 proof examples, and then the final video will cover 2 additional proof videos. Thank you very much for your time. Please make sure you watch the example proofs before you start the classwork.